Hey guys, it's Wojtek, and as per our fans' request, we're doing a tutorial on tags. Specifically, we're going to talk about how we can use tags to enhance our interactive interfaces to access one-to-many objects within our world. We're also going to use the lerp method to scale our interactive objects as we find them using our tags, and make them animate just a little bit better. So, let's get started. Alright guys, so before we get too far in our tutorial, let's take a look at what we did last time with our interactable objects. So I have the existing interactive object from our last tutorial, which is this little cone here. And if you recall, what we're doing is we're just shooting a line trace from it out towards the object. And then based on our interface and where we're aiming, we're just making it grow. And with our tags, what we're going to do is we're going to create a switch object, just something that triggers other behaviors within the environment. And what our switch is going to do is it's going to use tags to basically grow one-to-many of these cones. And in later tutorials, we're going to show you how to do some more fun stuff with tags and transformations. But for right now, let's just see if we can get a bunch of them growing at the same time. So, to do that, what I'm going to do is create a new class in our props folder, and I'm going to have it inherit from our interactive prop class, because I actually want to reuse a bunch of the stuff that's already in there. I just don't necessarily want it to scale when we interact with it. I'll show you how we can get around that. So there's our interactive prop, and we're going to use it as our base class. I'm also going to put this in our props folder. And we're going to call this our switch prop. And essentially, all this guy is going to do is toggle things off and on. Maybe switch is not the best word. Let's go with toggle. So this is just going to go off and on. And let's go ahead and create this class. This will just take a second. Okay, so we have our toggle prop, and as we can see, it inherits from our interactive prop class. So now what we want to do is we want to give it a thing to tag. Oh, tag, terrible word. We need some sort of identifier that will allow us to basically say, hey, this toggle prop interacts with objects of some other property. And to do that, what we're going to do is we're going to create a new property. It's going to be just edit defaults only. Blueprint read. Let's go read only. And it's going to be an f name. And tag, whatever we want to call this property. It's going to be our toggle tag. So this fname variable is essentially going to be the name of any tags we want this toggle prop to interact with. And right now we're just having one, but we could very easily make this an array of tags, so we could have one-to-many. And I'll show you how to do that a little bit later. But for right now, let's just go ahead and implement our toggle tag. Next thing we're going to do is we're also going to overwrite, if you recall, on our interactive prop, which inherits from our interactive actor interface, we have this interact implementation method. And in our toggle object, we want to overwrite this guy in order to implement our own logic, so we don't necessarily inherit from whatever's happening in the interactive prop. And we'll flesh this out over the next couple of tutorials, and we'll show you all kinds of fun stuff we can do with this. But for right now, let's just go ahead and overwrite our implementation. And let's go ahead and generate that. And if you notice some weird shortcuts and better auto-completion, I am using ReSharper. I switched over from Visual Studio Assist just because this thing is it's so much faster. Nothing to the folks at Tomato Software, but it's just super slow in comparison to ReSharper. So where were we? So our interact implementation. What this guy is going to do for our toggle prop is he's going to avoid calling the super on interactive prop. And let me just show you what's happening there. So in our interactive prop, what we're doing is we're basically saying, hey, is my object big? If so, set it to, sorry, if he's not big, set it to be twice the scale. If it's already big, then just flip it back and just off and on. So what we're going to do is we're going to migrate this type of logic over to our toggle prop, and then it's going to call this guy on our interactive code. So let's go ahead and make this work a bit. So first what we're going to do is we're going to iterate So we're going to try to get all of the actors from our scene. And to do that, we're going to use the tActor iterator. And what this guy does, and you'll notice my autocomplete is basically saying, hey, also make sure you include engineutils.h, because that's where this definition comes from. So I'm just going to bring that in. And our actor iterator is basically going to go over our world instance, and he's going to bring back any object of this class. So if I want to get more specific, I can bring back all of my actors and then do some casting lower down below and convert them to the actual objects I want to interact with. And this is essentially what we're going to do here. We're going to say actor iterator and actor iterator plus plus. So we're just going to move it up by one. No, sorry. We're going to move it up by one as we're going over this this set of actors. Now, to cast our actor, fairly straightforward. So now we have our actor, and in our case we could be casting this to another object, but I want all of the actors just so you can see all the sort of stuff that's happening within your scene. Now we want to do a quick check to make sure our actor is actually not null. We also want to say actor does not equal this, because we want to ignore this particular prop, as it will get picked up by this bit of logic when we pull it out of the world. So you always want to make sure you ignore yourself, or don't, depending on if your logic accounts for that. And then lastly, we're going to use our interface logic to see if our actor implements our uInteractive actor. So what do we do here? We said ensure actor is not null, ignore self if found, ensure we find actors of a specific interface only. Okay, so we've got a little bit of logic here now, and we're we're getting pretty close to actually now being able to interact with our tags. So far, we haven't done really anything with the tags. We just pulled back a bunch of actors. So, how do we now deal with tags? Well, we have two ways of doing it. So we can display all available tags for an actor, and the way you do that is we can simply iterate over fname tag actor tags. So I can basically say, hey, if my actor passes and he's interactive, cool, let's see what tags he has on him. And to do that, all we're going to do is just say g engine and we need the engine header for that. Otherwise, our autocomplete is going to be unhappy, as well as our compilation. So we're going to do add screen debug message, and we'll say -1 for the key. We don't really care about that. Let's say 5 seconds to display. Color. What's a good color? Oops. You know what? Let's go cayenne. And what else we got here? And what do we actually want to show? Let's say our tag. No, you know what? Tag plus tag. What else do we want to do here? You know what? Actually, we don't need any of this nonsense. This is all going to go away. So let's just show the tag. And it's complaining because we're missing 2 string. That's what it was. Okay. So there is our tag. And let's just run this to see what happens. So let me recompile and we'll hop back into the editor. Okay, so we're all recompiled. Now let's go ahead and create our toggle blueprint. So just in the props folder, I am going to create a new folder for our toggle. Just so everything is nicely organized. And we're going to create a new blueprint that inherits from our toggle prop class. And we're going to call this BP toggle prop. Now, you'll notice here is our toggle tag, the thing we're actually going to be using to reference other objects within our scene. But we're going to leave that alone for now. We're just going to make sure everything works with our existing objects. So I'm just going to give it a base mesh. And what do we want to do? Why don't we just do just a sphere? And then onto it, let's give it a material. Something highly visible. Instance, nickel, steel. Yeah, I'll go with nickel. That seems like a good idea. So we have our toggle prop, and it's just going to be this sphere object here in front of our cone. And what should happen is, based on our logic, we should iterate over all of the tags from any other object in the scene, excluding ourselves. So let's make sure that still works. Oh, that's right. So the reason this object is not working is we don't have a correct collision set on it. So right now I have an enemy that I'm just using for all of my testing, but essentially this would be like interactive object or prop or something else, because the line trace coming out of our player is expecting a specific collision type. So let's just flip that over to enemy, make sure that works, and cool. So we're interacting with our thing. That yellow message is just coming from our player character, specifically in our interact method. So there is the our log level and drawing the debug line. So let's get rid of this guy. And next time we recompile, we'll get that yellow message going in. But as I'm sure everybody noticed, we don't have our cayenne saying, hey, there's a cone there. And the reason for that is we don't have any tags on this object. So let's crack open the blueprint for our object, and let's give it some tags. So if and tags can actually be set on a couple of different things. They can be set on components. So if I go to my mesh and in my details I look for tag, you'll notice there's component tags. And components tags are essentially the same as sort of higher level object tags, where I can basically reference this base mesh by a specific tag. So if I have, 30 meshes and I only want to get the ones that represent, let's say, legs, I can say, hey, find me all the base meshes of a tag type leg, and I'll get an array list back of these types. Then I can perform specific operations on them. Let's say, changing materials, or adjusting the animations for those components or what have you. So those are component level tags. But we also have our general all-purpose actor level tags, and these are the ones that we're playing with. You'll notice if we go back here, off of the actor we have tags, and then if I wanted to get the tags off of a component, I could say base mesh. Is it called base mesh? What do we call this thing? Yeah, base mesh. Oh, because we don't have the actual component for components. Static mesh component. And then, when we say base mesh, you'll notice there's a bunch of these different tag methods we can actually get off of our components. So component has tag, component tags, current tag, etc. But we're not going to be worrying about those guys. We're just going to use our regular actor tags. So going back to our blueprint. On our actor, we're going to give it a tag, and we're going to give it a tag of cone. So now, when we interact with our sphere, look at that. We get the yellow text that represents our object, and we get the cyan text that represents the cone, because it found it. You know, there's a tag on that object. It found all those objects and showing the tags. Pretty straightforward. But you can also have many of these guys, right? So we can have cone, we can have object, we can have white, we can have pointy, and whatever other sort of attributes you want to give this thing for whatever uses you have. And now, when we show our list, you see they're all right there. There's a whole pile of them. And if we now go back to our scene and we say, oops, let's take this cone, and, duplicate these guys out. I'm going to get now a whole pile of messages. Look at that. So it finds all the tags for all the objects. 8 by 4 tags, and we've got 32 things that should be printing. If my math was even remotely accurate. Yeah, there's 4 of them. Close enough. So let's now actually do something with these tags. So this is one way of working, right? If I want to be able to get all of them at once. But what if I just want to work with a very specific tag? So what I can do is I can say actor has tag, and now in here I can pass in one tag. I can iterate over this and pass in many, or do other sort of mechanics, but in this case we just want to worry about one. So we're going to pass in the tag that we define as our toggle tag for our toggle prop. So it's going to target any object within that tag, or that has that tag, and do some sort of operation on it. So if our actor has a tag, then we can use our cool handy dandy interface call to now execute interact on that specific actor. Right? So if I recompile this, let's try it out. Okay, so let's see what happens now when we process our tag. Our toggle object using a tag. Disregard some of these animations. Look at that, we got nothing. And the reason nothing is working is we never actually set this value on our blueprint. So we never updated toggle tag to reference anything. And remember, we have a couple of these guys. So we can reference cones, objects, white or pointy. And I'm going to get rid of this. We'll leave cone and pointy. So on my toggle tag, I am going to make this guy look for cone. And now, when we play our game, look at that. Through what I presume is just magic. There's no actual computer code involved in this. It's all magic and fairy tales. We are able to grow and shrink our cones in unison. Pretty cool. We just use tags to basically affect the world around us fairly easily. But let's see how this now works with tags of different types. So if I take these 4 cones, actually, yeah, let's delete these 4 cones. And I'm going to space these guys out just a little bit, so they don't overlap when they actually grow. I don't know if this is close enough, but we'll find out shortly. Okay, and then I take 4 of these guys. Maybe not 4 of these guys. I'm going to take 1 of these guys. And we'll plop them over here. And in our... Actually, you know what? We're going to create a completely different object. So, we have our cone. We have this little box. Ooh, you know what? We're going to use the box. So the box is going to go right here. Or make our little sphere that works with these guys. And then we're also going to create another toggle. Just going to duplicate it. And this one is going to be a slightly different colored. We'll make it gold. And this guy is going to control this particular object, or rather, a couple of these objects. So, going back to our interactive definition, I'm just cracking open this little ramp. I'm going to give it a tag of some sort. So we're going to call this guy ramp. Cool. And then on our secondary toggle, we're only going to have it affect the ramp object. So, when we interact with this guy, our ramps are quite giant. So, why don't we... Oh, man. Alright, let's move these guys over here, so they're way the hell out of our way. And now, if I want to interact with the ramps, look at that. Big, small, big, small. This guy only works with the cones. Pretty cool. Now, this gives us... this is really bugging me. Let's raise this up so the camera can actually see the thing we're aiming at. So this is pretty cool for performing, straight up operations on multiple objects. But what if you want to, let's say, affect, one to many? Or what if you want to have a switch that, controls multiple things or controls them at different intervals? You can start seeing the puzzle possibilities from this type of setup. There's a lot of different combinations you can mess around with. But let me show you real quick how we can add just a little bit more variability. And what we're going to do, is we're going to modify our toggle property. So it's not a toggle tag, but it's actually a array of names So we're going to say toggle tags. And obviously this is not going to work, right? Because this was just for a single one. But what we can do is we can bring back this bit of logic that basically says, hey, I'm an actor. And I can iterate over all of the tags, right? Or I can simply say for fname tags to process, I can say toggle tags. And then in here, I can say if actor has tag to process, or tag to check, then do our interaction. And let me just rename some of these variables. Public field, tname tags. Okay, let's recompile and see what this looks like. Alright, so we're all rebuilt. Let's go back to our toggle objects. And you'll notice instead of a single value, we now have an array. So let's add 2 of these. So we'll have the, what color is this guy? Yes, we'll have our silver toggle hit cones and ramps, while our golden toggle is only going to hit the cone. When we run our game now, our gold guy is only affecting the cones, whereas our silver guy, and let me just raise him up as well, just so we can see a little bit better. And our silver guy is now affecting both sets of objects, right? This guy, little guys, and this guy, big guys. Pretty cool. Just using tags. And tags, I mean, you can come up with some very interesting scenarios. The amount of data and information you can store in a tag is limited, but you can get quite creative with, key value pairs to determine how you want certain things to operate. Now, lastly, because the switch is not super pretty, right? It just kind of pops up and down. What we can do is just add a little bit of sprinkling logic around our transformations to use lerping and scale the objects appropriately through our tick. And to do that, pretty straightforward. We're going to leave this bit of logic in our interaction as is. So we're going to do that. And in our tick, what we're going to say, if is big. Actually, we can just copy over this whole bit of logic. So if I'm not big, set me to a scale of 2. Otherwise, shrink me down. So we're going to make sure b is big equals false by default. And let's go ahead and recompile. All right, that was pretty quick. Let me just make sure everything is as expected. Okay. Oh, and So here's a slight problem, because our toggle prop, it inherits from our interactive prop. You might have noticed that the logic is a little bit screwed up, where because I was setting this to false, it was automatically scaling it to go up, and obviously we don't want our interactive props to be affected all the time by the scaling, especially when they're coming in from toggle prop. So to do that, you can have a couple of different ways. You can overwrite the tick such that it doesn't call the super, or you basically put in a couple of additional conditionals that don't force you to scale the object. So we can say if it's big and b can scale. So on our interactive prop, we're going to add a new property, and we're actually going to make this guy a public u property edit defaults only, blueprint read only. And this is a bool b can scale. And by default, for our toggle prop, we're going to make this guy, oops. You know what, we don't even need to do this. We can just set it right in the blueprint. But, by default, I'm going to throw it in anyway, just to be on the safe side. So we're going to create a constructor. Inside of that constructor, we are going to say b can scale equals false. So by default, this guy doesn't scale. Our interactive props, by default, can. It's true. And now our logic should basically be if b can scale. Oops. Do this. And we'll get rid of all this junk. Okay, let's recompile and see what this looks like. Alright guys, we're all recompiled. Let's take a look at our objects, make sure our flags are set correctly. So our, what is this, our cone, you can scale by default. Our ramp can scale by default. And let's take a look at our toggle objects. And these guys can't scale. So there we go. That guy scales that guy, and okay, so we're all good. And we're using the tick to basically apply the scaling setting. But what if we want to scale so it's a little bit, just a little bit smoother? Right now it's kind of jarring. So let's use just a quick lerp between these scaling directives. So it basically linear interpolates the scale over a period of time, basically creating a little animation for our game. And to do that, we're going to use the fmath function, and we're going to use lerp. And the lerp is basically going to take some vector and then a target vector. So in this case, since we're going from big, so if I'm big, I want to shrink to small. So we're going to get the base mesh. Whoa, that was strange. Base mesh. I'll just get rid of this for now. We're going to get the base mesh component scale. So this is the current scale of the object at that point in time that we're doing the flip. And we're going to go from that up to 2. so twice the size. And then the alpha, the last parameter, is over, what period in time. Like how quickly do we want this thing to move? And you see the alpha ranges from 0 to 1. So we're going to set the alpha range to 0.5. And that should give us a nice little lerp. Now we're going to do the same thing for the component below, and we're again going to say fmath lerp, and we're going to use the base mesh. Okay, component scale, and we're going to interpolate it back to a 1 scale, and we're going to do over 0.5f as well. So let's recompile this and see what it looks like. Alright guys, let's see what our lerping is now going to do. Disregard the random kicks. And, oh, there we go. Look at that. So now they smoothly grow and shrink. Basically from wherever they started from. And likewise, so do our other objects. And, if you're feeling saucy, you can mess around with different scaling factors, the various transforms, rotates, and, come up with some interesting combinations of things that scale. Now, one thing maybe some of you are wondering is, hey, does this actually work if I am just a little bit closer to the object, if I'm standing on the object? And the answer is yes. You just need to account for some of the collisions. So if I take this guy and I hit my trigger, you'll notice my character grows fairly well, or moves up and down with the scale of the object. If I were just to do a scale without any linear interpolation, he would fall through the mesh. Just because there isn't enough time for the engine to process sort of the location of the player relative to the thing that is he's standing on that is being scaled. So, there we are. We have a couple of interesting little usages for our tags. And in later tutorials, I'm going to show you how to make a couple of puzzles using these. Specifically ones that rely on transformations as a way of manipulating the environment. So, thank you for tuning in, and hope to see you next time.